Okay, so we're going to do a couple word problems to do with Venn diagrams. So this problem, let's read it first. In a group of 100 customers at Big Red's Pizza Emporium, 80 of them ordered mushrooms on their pizza and 72 of them ordered pepperoni. 60 customers ordered both mushrooms and pepperoni on their pizza. So you see that this is talking about an intersection where two things overlap. There's only two toppings that they're talking about, mushrooms and pepperoni. So we would have mushrooms would be one of our set, and pepperoni would be the other set. And we were given the number of pizzas, or the number of customers that ordered mushrooms on their pizza. Number that ordered mushrooms is 80. The number that ordered pepperoni was 72. And the number that ordered both mushrooms and pepperoni was 60. And this 100 up here would be the number in the universal set. So altogether it's 100. You notice they add up to more than 100, so that looks like it's not quite right, but what happens is that a lot of these overlap. So if we say this is the mushroom and this is the pepperoni, then we can say in here in the intersection is both mushrooms and pepperoni. And now pepperoni is 72, so this whole circle should add up to 72. We've already got 60 in there. So there's 12 that ordered just pepperoni, 60 that ordered both pepperoni and mushrooms. And then the mushrooms themselves, there was 80, but we've already got 60 in there. So 20 ordered mushrooms only. And now, how many does this add up to? So that adds up to 80 for the mushrooms plus 12 more. 92, and there was 100 people altogether. So there's 8 people that didn't order mushrooms or pepperoni, so we'd put that outside. And then once you have your Venn diagram, you can answer any questions. So question A says, how many customers ordered mushrooms but no pepperoni? So mushrooms, that would be in the mushroom circle, but we don't want pepperoni, so we don't want these 60. So this we would say, if you wanted to write the actual set, they ordered mushrooms and not pepperoni, is 20. B, how many ordered pepperoni but no mushrooms? So pepperoni and no mushrooms. Oh, not P, this should be number. Sorry, number. Too many P's in here. Okay, so forget about that. So pepperoni, but not mushrooms, so not the 60, so 12. And C says, how many customers ordered neither? And that would be these 8. So to write that, you don't usually have to write this, but we could say not pepperoni and not mushrooms is 8. And if you were shading any of these, so you wanted, this is the intersection, both, you compare them both in the mushroom circle and not in the pepperoni circle. So that would be this part. That's how the shading helps you. Sometimes you'll be given some expression and you would shade it to see exactly what we're looking for. Like this one down here is shaded outside. And I wrote that this way, but you could also, you could also write it pepperoni union mushroom, that's everything in here, and then put a big bracket and say complement, so not what's in there. Okay, so the next question. At Dan's automotive shop, 50 cars were inspected. 23 of the cars needed new brakes, 34 needed new exhaust systems, and 6 cars needed neither repair. how many needed both. So they're actually asking for the intersection here, and they don't give it. Let's write down what they did give. The number in the universal set, the total cars was 50. 23 needed new brakes. So let's say brakes. And the other is exhaust. So the number that needed brakes was 23. The number that needed exhaust, 34. 6 is neither. So if you're looking at that, we've got brakes and exhaust, and they're talking about this out here. Okay, so we know that. We know the total adds up to 50, and we know that these add up to, the brake circle adds up to 23, and the exhaust circle adds up to 34. It doesn't look like enough information to be given, but it actually is. And the way that this works is if we have, there's a counting formula, and the counting formula says this. With two sets, it says that if we want A union B, we can take the number in A, add the number in B, and subtract the intersection. So if we look at this, so if we take the number in A, just grab a couple highlighters here. So this is saying take all of A and add to it all of B. So if you notice what happens, if I add all of B, let's see, so I colored all of B in blue and all of A in yellow, and you see the green part in the center, that was colored twice by accident. So if we take it out, then we have these three pieces once. So A was these two, B was the other two, and then we need to take out the center because we've added it twice, and that gives us the union. What else in counting do we know? We know that the number in the universal set are all of these numbers added up. So that actually would give us the number outside here. So the number that's not in A or B, plus the number that is in A union B. Right? So A union B is all of this. The number outside would equal the total. And we sort of have that scenario up here. But one more thing I want to say, that we could say the number, suppose we want the number not in A, we could take the number in the universal set and subtract the number in A to get the number outside of A. So you can do different things like this. If you think about it, this take everything, subtract all of A, and we get what's outside of it. All right, so using a little of these kind of ideas, we have the 6. So what do we know about the other 3 parts? So we've got 3 parts here, and all 4 of these numbers, including the 6 plus these 3 numbers, have to add up to 50. So everything has to add up to 50. The number in the universal set is 50. The number not in B or E is 6, so the number in B or E has to be 50 minus 6, which would be 44. So these 3 add up to 44. Now look at this formula right here. If I know how much are in the union, 44, I know how many are in each of them individually, then I have one unknown to find, and I can find the intersection, the part in the center. So let's just go down here, and we'll use the proper letters, a little block around this. These are formulas. And you don't necessarily need to memorize these formulas because, or you could write them down on your cheat sheet for the exam, but you don't really need to because you can usually reason through if you know what you're doing. So we know that these three add up to 44. So let's say the number in B union E is equal to the number in B plus the number in E, and take out that center because we would have counted it twice. So we found that this was 44. These were given as 23 and 34, and we want to find this one. So this is 44. 23 plus 34 is 57. And you can see 57 minus what is equal to 44, or rearrange the equation. Okay, so what we end up having is 13 in the center. The number in B was 23, so that whole circle has to add up to 23, so we're missing 10. Now 10 plus 13 is 23. This circle has to add up to 34, so we are missing 21. 13 plus 21 is 34. And the whole thing has to add up to 50, but we were actually told this 6. And now we can answer any questions. So, what were the questions? Let's look back. Here's our diagram. So question, the first one said, how many cars needed both repairs? Well, we found that was 13. How many cars needed new brakes? So in the brake circle, but not new exhaust. So not these 13, so that would be 10. New brakes in the brake circle, but not new exhaust. Okay, so let's look at a third example. If you want to try this on your own, you could pause it and give it a try and then watch. But I'm going to go ahead and do it. So this says a survey of 80 neighborhood kids showed that 50 own a trampoline, 35 own a swimming pool, and 40 own a swing set. Now you notice there's three things here. So let's call this trampoline. Let's say swimming pool. And swing set. And we'll write down what we know. So 80 kids, that's everyone. 50 own a trampoline. 35 own a swimming pool. And 40 own a swing set. 16 own a trampoline and a swimming pool. Trampoline and swimming pool. 16. 11 own a swimming pool and a swing set. That was 11. 26 a trampoline and a swing set. Only 2 of the kids didn't own any of the 3. So that's the outside. So didn't own any of the 3. So not a trampoline and not a swing set and not a swimming pool is 2. So the problem here is that we always need to know that very center. And so this counting formula is a little trickier for 3 sets. So for 3 sets, I'll show you what it looks like. So let's put A, B, and C. Oops, union C. If we add up all the sets, so let's look at what happens here. to develop the formula. It's a bit longer. And I don't think you should memorize it, but let's color these in yellow. So what if we color all of A, so we've added these 4 parts in, and then we color in B what we've already added too much of is this intersection. You see we've added that twice. So let's write that down right away. We need to subtract off the intersection of A, intersection B. So that allows us to count that just once. Now if we add C in, what happens? We've now done the same thing. We've added this part too much and that part too much. So we actually would have to subtract off all of those intersections. So B intersection C and subtract off A intersection C. So the 3 pairs of intersections. Now if we do that, what happens is we've subtracted this, this, and this, and we're going to end up with none of the middle left. So you could see this maybe if we put little pieces of paper on them as we do it, which you might want to try if you can't visualize this. So what happens is we've taken out all of the center, and that was too much, so we need to add back in the very center. And so this would be the formula. So it's got 1, 2, 3, 4, 5, 6, 7 parts. And that's all we use usually just to find this very center piece. So let's see up here if we know all of the parts so that we can find what the center is. And then you always need that center to get started making your Venn diagram. So let's put what we do know. Make sure you, when you draw your Venn diagram, the circles are big enough to put numbers everywhere. We know that this is 2. And that's basically all we can write, because the rest of them are added up from multiple parts. So we're going to call this trampoline, swimming pool, and swing set. So what we need to do is find this very center, and then we can work our way out. So if we fill in this, we would know that this is 2. The whole thing, the whole universal set, adds up to 80. So all of these parts in here have to add up to 78. So T union swimming pool union swing set has to equal 78. That's the union. So filling in our formula, we'd have 78, A plus B plus C, so add each of them up. 50 plus 35 plus 40. Take away all of the intersections, which are these 3, 16 minus 11 minus 26, and we need to add back in the very center, and that's what we're looking for. So let's work all of this out. Oops. Um, 72. So 78 minus 72 is 6. So we know the center is 6. And then we can work our way out. So if you take our next intersection, so these intersections right here, this is T and swimming pool. So the T and swimming pool, trampoline and swimming pool, have to add up to 16. We already have 6 in there, so that would be 10. Swimming pool and swing set, we have 6 in there. We needed to add up to 11, so 5. And 26 for, oh, did I put that one in the wrong place? I did. So that should have been 5 here. And this is 26, so in here would be 20. Okay, I've got them in the right place. Then you work your way back here. So 40 is swimming pool. So all of this, 20 plus 6 plus 5, that's 31. And we want 40 altogether, so we're missing 9. Swimming pool is 35, so let's look at what we've got in this circle. 10 plus 6 plus 5 is 10 plus 11 is 21. It needs to add up to 35, so 35 minus 21. I shouldn't have to do that, is 14. That was the swimming pool. 35, and we already had 21 in there, so 35 minus 21 is 14. And that's what I put in, was the 14. Same thing here, we added up. This was for the swing set. This was for the swimming pool. And for the trampoline, in the trampoline circle, we've got 26 and 10, which is 36. And the trampoline should add up to 50. So 50 minus 36 is 14. So this should be 14. And do we have a number in each spot? Yes. They should add up all to 80 if you didn't mess up, because the whole thing adds up to 80. So let's just double check. I'm just going to type all the numbers in. And don't forget the 2 out here. Adds up to 80. Perfect. And now we can answer the questions. And the question said, only 2 of the kids didn't own any of the 3. How many kids owned all 3? Oh, well, 6. And I guess we didn't need to fill it in to get the 6. So 6 owned all 3. And I could ask other questions. Say, for example, how many owned a trampoline but not a swing set or swimming pool. So own a trampoline, that would be any of these in this circle, but not a swing set or swimming pool, so none of these, just 14. Okay, so you could ask any question. Okay, one more. The last one, and this one talks about a class of 40 on what pets they like. The choices were cats, dogs, and birds. So 15 like cats, 10 like birds, 30 like dogs, cats and birds, dogs and birds, cats and dogs, all 3. Draw a 3-circle Venn diagram to illustrate the data. And this one is good because you should be able to do this actually. Look, this is all 3, and so that goes in the center. Let's label these cats, birds, dogs. Okay, so what I'm going to ask you to do is pause it. I'll keep going, but you pause and then come back and listen to the rest once you get the numbers put in here. Because I think you can do it. There's nothing tricky. You don't need any formulas. You can just, we have the center already given, so then you just work your way out. So pause it and see if you can do that. Okay, so all 3 was put in the center, so then cats and dogs is 13, so that would be this petal-shaped piece. We've already got 3 in there, so now we need 10. 5 like dogs and birds, and we've got 2 in there, 3 in there already, so we need 2 more to be 5. And then cats and birds is here. We've got 3 in, and we want 4 altogether, so 1 more. And then 30 like dogs. Dogs would be this circle. So in that dog circle, so far I have 10 plus 3 plus 2, that's 15. So I need 15 more. Um, 10 like birds. So in the bird circle, what do we have already? 1 plus 3 plus 2, that's 6. so we need 4 more. And the last one, cats, 15 like cats, so this has to add up to 15. So far we have 10 plus 3 plus 1. That's 14, so we need 1 more. And then we should be able to get a number in the universal set. So we look for a total, 40, or something to say how many don't like anything. Now that adds up to 40, so we need to add all of these numbers up. Right, just add all of those up. And that gives me 36, and the total number was 40, so we need 4 that would go out here. And you can put it anywhere. It's usually found in one of the corners, though. Okay, so that was part A. How many students didn't like any of the 3 pets? That would be 4, the outside. How many students said they like dogs only? So here's the dog circle, and 15 are by themselves. These other 10, 3, and 2 like something else. How many students said that they like cats and dogs? So that's, you're talking about these 13 people like cats and dogs, but not birds. So not the 3 that are in the center, so just 10. Okay, cats and dogs are these 13, but these 3 in the center like birds because they're in the bird circle, so the 10 are the only ones that don't. And that is all for Venn diagrams.